Assalamualaikum, Dr. Nazmi. Boleh Dr. Nazmi memperkenalkan diri dan juga beritahu tentang bidang kepakaran Dr. Nazmi?
Kepakaran saya menyiapkan assignment ke student yang tak siap-siap. Dan juga melayan budak-budak macam kau. Kau tahu tengah kerja. Kenapa tak panggil awal? Ha? Hobi kan buat kerja last minute. Apa benda? From Fakulti Pertanian. Ya. Bidang kepakaran. Apa?
Our first question to Doctor is, how do plants adapt to nutrient-poor environments to ensure adequate mineral uptake for growth and survival?
Say again. Say it again. No, do you want me to do this in English? Ke kau nak aku buat cakap bahasa Melayu? Boleh je mana-mana. Boleh je mana-mana. So I answer in English. Macam tu. No, sekarang ni nanti kalau kau tak faham, kau tak nak tanya aku dah. Aku nak cuti dah.
Aku ada video.
Lepas tu, okay. Say the question again.
Alright. My question is, how do plants adapt to nutrient-poor environments to ensure adequate mineral uptake for growth and survival?
How do plants, you mean aquatic plants?
Both aquatics and land plants.
Aquatic and land plants?
To adapt to nutrient-poor environments.
To nutrient-poor environments.
To ensure adequate mineral uptake for growth and survival.
So for land or terrestrial plants, so basically plants have organs, roots, shoots, leaves, stems, flower, fruits. These are all organs in plant, and organs have specialized function. When it comes to absorbing nutrients, even though commonly associated with roots as the one doing the job, actually plants is a bit special because the other parts of the plant can also absorb nutrient. Okay, so the roots, it absorbs nutrients in the soil while doing the water uptake. Much of the nutrients in the form of minerals is actually dissolved in water. So these ions come along with the water uptake, going up the plant through the capillary action, cohesion, addition, that kind of thing, to nourish the entire plant. So what about plants that are aquatic in nature? So there are a number of mechanisms involved. Roots could also be responsible to that, but roots for aquatic plant is actually mainly for anchorage. Okay, because the ground in the pond or in the water bodies is rather soft, so the plants need to anchor firmly to the position. So the primary mechanism is the same. Whatever nutrients or minerals that have dissolved in the water will be absorbed by the plant's organ, primarily root. Other parts of the plants, such as stem and leaves, are also able to absorb the nutrients because the organs, such as leaves, have stomata, the microscopic pores that are present on the surface. So these stomata can act like not only the portal for gas exchange, but also the entry for the nutrients in the form of dissolved liquid. Okay, so these get absorbed into the plant and can be assimilated as well, right? To address, so the further question about that is to address insufficiency, is it?
Yes, it's a nutrient-poor environment. So how do they adapt?
Okay, so for poor environments, on the surface of the roots, let's focus on roots, even though I've mentioned that other parts of the organs can also absorb nutrient. Roots got cells You see, on the surface of the cells are actually equipped with various ion channels. These ion channels can allow the uptake of dissolved nutrient, that is the dissolved minerals, against concentration gradient. Active transport. They use energy. So even though the concentration in the inside of the plants is not in equilibrium with the outside, the cells, the root cells, can do the active uptake to allow more and more nutrients to come into the plant. So that is one way. The second way is actually for the poor soil. This is the special adaptation by carnivorous plant. You see, carnivorous plants have present in the terrestrial area as well as in the aquatic area. The famous one in terrestrial area, that is the Venus flytrap. So the Venus flytrap, have you seen it? So Venus flytrap, on the surface of the flap, it's like a flap there are micro hairs there. So these micro hairs got some kind of memory to it. So the moment it detects a number of specified movement due to the bristling against the insect's legs or something, this will trigger these micro hairs to send signal and causing the flap to close. So this adaptation is actually stemming from the needs of the Venus flytrap that in nature grow in bog or pit area. Okay, so bog and pit area is very low in nitrogen, super low. You only get moisture, but that's pretty much about it. So these recently trapped insects, worms, small grasshoppers, or tadpoles perhaps, will be digested by the flap. This flap actually modified leaf. It was once a leaf, but since the plants have detected that's not much nutrient in the soil now, I need a further digestive structure to get nourishment. So the leaf modify itself to become the flap. There are many other examples, like the peaches plant, what's that Malay? Periuk kera, Sarracenia, sundew. Yeah, that's for the land plant. For the aquatic plant, I don't think there's so much the carnivorous. I can only think of one, which I learned during my internship. These students, they know lah. Just morning I was talking about my practical internship in England. So during that time, I learned about this aquatic plant called bladderwort. Bladder, like a bladder. What's the Latin name for it? The botanic name, Utricularia vulgaris. So these plants have it looks normal, but the root of it got a small sacs attached to the root, and these small sacs not just to contain air, but it's actually a vacuum bag. There's a difference of pressure between the inside of the bag and the surrounding water in the pond. So the moment there is like a small fish or maybe nematodes or any small aquatic animals rubbing against the hairs of these bladderworts, this bladder will start to open its opening, and this is causing a gush of water to get in. Yeah, if I'm not mistaken, this force is about 5G or 6G. The impact, the rush of the water that gets in, not the 5G telephone DG kau tu. Ni gravitational force. You learn your physics, right?
Yes.
Yeah. So it gets in and it suck. The moment it suck in, there's a digestive enzyme in the bladderwort, and then the small. Yeah. So that will supplement the plant and ensuring that even though the soil nutrition is poor, that's fine. I'll just eat other people. Okay.
Okay. Apa?
Okay, so for the next question, how climate change affects the efficiency of water uptake and mineral absorption by plant roots?
Climate change.
Yes.
Climate change or any other environmental problem.
Climate change effects on water.
The water uptake, efficiency, and mineral absorption by
Okay.
the plant roots.
To start with, climate change will definitely causing the water efficiency to become not that great. Okay, because let's face it this way: when our planet Earth gets warmer, the plants will start to transpire a lot. To cool down its body. For example, like the rice. This will cause more water to be released back to the atmosphere in the forms of water vapor. Plants needs this to cool down, but in the process, this water, once it is in the form of water vapor in the atmosphere, there is no guarantee it's going to come back in the form of liquid back to the paddy field. Yeah. So this actually will end up in the form of when scientists do the analysis, the water use efficiency for the paddy plant due to the climate change is very low, because in order to produce 1 kilogram of rice per us, you need the plant use about 1,400 liters of water. That's a lot. Just one kilogram of rice that you eat, you need 1,400 liters of water. Can you imagine how much?
Yes.
For the rest of the year, how much water is released back? So this is not efficient. If you compare that amount to the hydroponic vegetables, that hydroponic tank is about 50 liters, and then you can grow multiple number of plants. So 50 liters, you got 1 kilogram of green vegetable. That's water efficient. Rice, one kilogram of rice, 1,400 liters of water lost. Yeah. So climate change is not that great because of this reason, warming effect and so on. And the other thing is climate change is causing certain area to experience heavy rain more than usual. And when this happen, that actually causing the leaching of nutrient from the soil. Yeah, the nutrient actually stay in the soil. Regular rain, that's fine. But when there's a sudden a downpour of rain, torrential rain, that's gonna cause all the leaching to the nearby area. So that's not great. Yeah, that's why people need to prevent the climate change from happening. What do you call it? Climate change mitigation. You need to lessen the effect of climate change. Okay? Does that answer the question?
Yes.
Okay.
So
Dah.
that's all. Okay, so that's all from us, and thank you and Selamat Hari Raya.
Okay. All right. That's very easy. Are you sure?